a star called T, capital letter T, Coronae Borealis. So this is a star in the constellation Corona Borealis. Corona Borealis, from the Latin, simply translates to northern crown. The system is about 2,600 light years away. So of course, anything we observe today already happened 2,600 years ago. In the northern hemisphere, we have Corona Borealis, and one of the stars in that constellation varies in brightness significantly, explosively. And so the way we identify variable stars in a constellation is we start lettering them from R. So this is T Corona Borealis, RST. It's the third discovered variable star in the constellation Corona Borealis. Okay. It's been known for quite some time that this thing, the luminosity varies, and then one day it explosively varies. On a level where if you didn't know it was in the sky and then it exploded, you would say, oh, there's a new star in the sky. A new star. What's Latin for new? Nova. That's Latin for new. So this category of variable star, this category of explosion, has come to be known as nova. So, T Corona Borealis, what's going on? There's a red giant and a white dwarf, and the white dwarf is dead. It's glowing from leftover heat from when it was an authentic star. The sun will die as a white dwarf. When the sun in 5 billion years sheds all of its outer layers, it will reveal a dense core about the size of the Earth. That will be a white dwarf that will slowly cool over the eons. But this white dwarf is in a binary orbiting system with the red giants. And red giants like becoming bulbous, and they keep expanding and expanding. And there's a balance point, a literal balance point between these two objects, where if the expanding gas crosses that balance point, it's a gravitational balance point, then it's no longer gravitationally bound to the red giant, and it will fall into the white dwarf. So there's a gas transfer. And this transfer point, as the red giant gets larger and larger, there's what we call a lobe, an envelope of space around it. And it was first described mathematically by a fellow named Roche. So it fills this Roche lobe, and the gas crosses over and lands gently on the white dwarf. So now we have hydrogen on the surface of a white dwarf.